Good day, everyone, and welcome back again to this chemistry simplified, where we demystify all tough topics, make all topics look very simple with avalanche of mnemonics, shortcut, and sheet code to make all tough topics look very simple to you. All right, without wasting much of our time, so in today's channel, we are going to be explaining a particular topic which is very common in UTME, which is commonly known as JAMB. The topic is redox reaction. Redox reaction. Alright, without wasting much of our time, so I'm still going to dedicate a particular video to explain it in details. But because of the exam we are approaching, which is JAMB, so I'm only going to explain how to balance redox reaction in today's class. So don't forget, if you are a chemistry student, you should know that redox reaction, redox is two words combined together, which means reduction, oxidation, reaction. Reduction, oxidation, reaction. So I'm going to be explaining, you know that these two terms are defined in various ways. We can define them in terms of oxygen, in terms of hydrogen, in terms of electron loss or gain, in terms of oxidation number, and in terms of negativity or electropositivity. So just like we have promised, I'm going to be giving us a very shortcut to remember all these definitions. But the shortcut is for what? Is for oxidation. The shortcut is for what? For oxidation. So and the shortcut is what? Adore is LIONEL. Just add this. Now look at it very well. Adore is LIONEL. Adore is the name of person, very common one. You can remember it very quickly. That means a male. LIONEL. You know Lionel Messi now. That's very common. Alright. So what now the next we are going to do? Once you have written this, Adore is LIONEL. So you are going to what? Take the letters in 3-3. Take them 3-3. So what do we have first? ADO. Adore, right? Adore. So we have ADO. So what's the meaning of ADO? ADO is what? Addition of oxygen. So after ADO, what do we have? REH. We have REH. What's the meaning of REH? Remover of H is what? Hydrogen. Are you following us now? So what's the next thing? ESL. What is ESL? ESL. So we have what? We have electron loss. Then we have ION. What's ION? ION, we have increase. Increase in O is what? Oxidation. And N is what? Number. Then we have EL. This one, also it sounds like what? EL, electronegative. Last one is what? Just say addition of what? Of electronegative element. Alright, do we understand? Now look at me very well. I said this shortcut is for oxidation, and you know that they are vice versa, like they are opposite of each other. Whatever that is go for oxidation will be back for what? For reduction. Whatever that is forward for oxidation will be backward for reduction. So now I said the shortcut for oxidation is what? Adore is LIONEL. ADO, addition of oxygen, is oxidation. Why? Reduction will be what? Removal of oxygen. So if oxidation is removal of hydrogen, what will be for reduction? Like that. Addition of what? Hydrogen. Very good. If oxidation is electron loss, what will be for reduction? Electron gain. Good of you. If oxidation is what? Increase in oxidation number. What's the correct answer? Do you get that? Put that in the comment section. So that was what? Decrease. You can pause it and answer the question. That was decrease in oxidation number. Very good of you. Why the last one? If oxidation is addition of electronegative elements. Now pause the video and answer the question. So what will be for reduction like that? Yeah, if you have done that, that's very good of you. That will be what? Addition of electropositive elements. You know we have electronegative and we have electropositive. Very good of you. Now, but what I want to actually explain here is how to balance redox reaction. And we can balance redox reaction in 3 medium, but 2 common medium that is most textbooks. The first one is a very simple one, but not that too common. You cannot even see it in JAMB, which is neutral medium. So you can balance redox reaction in a neutral medium, in an acidic medium, and in a basic medium. But today we are going to be focusing on how to balance it in a what? In an acidic medium. So now this will be the part 1 of the video. So I'm going to make it the second part of the video. So to balance it in a basic medium. Now let's go through balancing in acidic medium. Now, just this video is going to be very brief and deep. Just follow me. Now, balancing acidic medium. There are some rules. As I said, I think I got a recommendation for this video from one of my students to just like do a video on how to balance redox reaction in acidic medium. So I have to just make it up today and actually make sure I do the video. So I'm going to be having another separate video to explain in details everything about redox reaction. But there are some rules that we must ensure or have it here in our cerebrum how to balance redox reaction. Rules. Number 1 thing to note is to identify the oxidation site and the reduction site. The second thing is to balance all of the atoms in that particular questions apart from what? Apart from oxygen. Because when you see oxygen in the question given, it depends on the medium. Then after you have balanced all other atoms, then you now balance the charges. You balance the what? The charges. Then after you have balanced the charges, I hope you have jotted this thing down. Now let me recap. Number 1, if you have to balance redox reaction in acidic medium, the first thing in every redox reaction is to locate the oxidation reaction and reduction reaction aspect. Do you understand? After that, you balance all other atoms apart from oxygen. And number 2, you balance the charges. Because I said that balancing of oxygen is medium dependent. So there is a way you balance oxygen in acidic medium and there's a way you balance oxygen in what? In a basic medium. But so far that we are using acidic medium, these are today, balancing of oxygen in acidic medium is that when you have one oxygen atom, you balance it with one water molecule. When you have one oxygen atom, you balance it with what? With one water molecule. And don't forget that when you are trying to balance oxygen, you balance it with water. You have then introduced another entity, which is what? Hydrogen. Then you are now going to balance the hydrogen atom in that water with a proton, which is hydrogen ion. Do you understand? Now let's use a sample to actually understand what we are explaining here. Now we have an example here. If you have ion 2 plus to react with MnO4 minus to give ion 3 plus Mn2 plus. Now, how do you know if this reaction is a redox reaction? So you have to look at the change. The very common one is to look at them with what? With their oxidation number. And there are some rules on that oxidation number that you have to take note of very well. But because of our time, I'm not going to go into that details because I want to make the video as short as possible so that you can grab the real gist there. Now, look at it. But the number 1 rule I'm going to tell us here is that if you have a monoatomic ion. Now, what do you call ion? Ion is an atom or group of atoms that possesses an electric charge. Now, what is the charge on ion here? You know, ion is Fe. What's the ion here? 2 plus, right? Now write it under it. We have 2 plus. That is the ON. If I say ON in this class, what do I mean? Oxidation number. So the ON of ion here is 2 plus. The ON of ion here is what? Is 3 plus. Now if you look at it now from ion here to here, it's a simple mathematics. From plus 2 to plus 3. Is that increase or decrease? That's what? Increase. And now come back here. Increase in what? Oxidation number. That is what? Oxidation. That means ion that goes oxidation. Do we get that now? Now, but here to this place, you have MnO4 here, but you have only manganese here, which means that it's only this manganese that undergoes oxidation. But the oxidation number of manganese here, that is plus 3. Manganese here is what? Is plus 2. Because it's also a monoatomic ion. But here, we have to calculate it. There's one of the rule. This substance you have here, this entity is known as radical in what? In chemistry. And a radical is a group of atoms that possesses an electric charge. And how do you know the ON of an atom there? There's one rule also I'm going to give us now. When you have a radical, the rule states that the algebraic sum of the oxidation number of a radical is equal to the charge they carry. Let me repeat. The rule states that the algebraic sum of oxidation number of a radical is equal to the charge on that radical. Now, what is the charge on this radical here now? -1, right? Now let's quickly find the ON of manganese in this. Let me use this space to find that so that we can come back to our balancing. We have MnO4 minus. Are we? Now we all equal to -1. Are we getting it now? So what are we looking for here? Manganese. Mn. Now the algebraic sum, that be plus. How many atoms of oxygen do we have here? 4. Multiplied by what is the ON of oxygen? Oxygen is -2. Don't worry, I'm going to dedicate a particular video to explain everything here. But it's actually very, very simple. If you are preparing for JAMB, you should at least have an idea of how to calculate or find ON of an atom in what? In a radical. Now be all equal to -1. Now we have mathematics. We now have Mn plus 4 times -2 will give us what? -8 equal to -1, right? Now Mn plus times will give us -8 equal to -1. Then you take the -8 to cross over this bridge, that turns to what? +8. Now we now have equal to -1 plus 8. -1 plus 8 will give us what? +7. Which means that the ON of manganese in this compound here is +7. That means manganese from +7 to +2. Is that increase or decrease? Yes, very good of you. That is what? That is decrease. And if you have decrease, that will be what? Reduction. So we have now done the very first thing there, which is what? When you have identified the oxidation and the reduction site. Now, what is the oxidation site here now? We have oxidation. Sorry. Which one undergoes oxidation? Our iron, right? We have Fe2+ to give us Fe3+. Now, and the one that undergoes reduction is what? MnO4 minus to give what? Mn2+. Is that taken out? Now, what the second rule is to balance the atoms. Now, if you look at it very well now, we have one ion. The atom is balanced. We have one manganese and one manganese. So, and I've explained that the oxygen is what? Is medium dependent. So, we are not going to balance what? The oxygen. Now, balancing of what? Of atoms. And I've explained. You can start with anyone. You can balance with what? With charges. Now, let's start with balancing of atoms. I think the atoms there is complete. So it is only oxygen that we have not what? We have not balanced. Now, if you now want to balance charges, now another rule is that if you are balancing charges, you have electron. What do I say? If you are balancing charges, you are going to have electron. And what charge do you have on your electron? Electron carries what? Negative charge. Now let me clearly explain something for you here. It's very, very simple. Now, simple mathematics. If you have +3 here and +5 here, and the rule is that you want to make them equal. That's why we are balancing, right? You want to make them equal. So I have to add electron. So what number of electrons are you going to add, and where will you add it? Now, if you have +3 here, +5 here. How can you make them equal? You can make them equal if you subtract 2 from this place. Do you understand? That means if you, and it's going to be adding of 2 electrons. An electron is what? Negatively charged. Do you understand? That means +5 minus 2 here will give us what? +3. So they are now equal. Do you understand what I explained here? So you can backward it and what? And get it. So if you have +8 and you have what? 2 here. Now, where are you going to add electron? Where? Very good. You are going to add electron here. Why? How many electrons are you going to add here? That would be what? 6 + 6 electron. So that means this plus, it's not that you are adding it, because electron is what? You are just adding electron. And electron is negatively charged. That means you have +8 minus 6, What will that give you? Plus 2, and this will give you plus 2. Very correct. Now, that is what you bring towards here. We have Fe 2 plus to give Fe 3 plus. You have plus 2 here and you have plus 3 here. So where are you going to add electron, and how many electrons are you going to add? At the right hand side or the left hand side? Very good of you. At the right hand side. How many? Just 1. That's plus 1 electron. So that means you have 3 minus 1. That will give us what? 2. So they are now balanced. Now coming back to this place, we have MnO4 minus to give us Mn2 plus. Don't forget that the Mn here is what? Plus 7. Mn here is what? Plus 2. So where are you going to add electron, and how many are you going to add? Very good of you. You are going to add electron here. And how many are you going to add? 5. Because we have 7 here initially. Have a minus 5. So you are going to have plus 5 electron. You have balanced the what? The charges. Very good of you. So what's the next thing we are going to do like that? We now want to balance oxygen atom. So you are balancing on what? Oxygen atom. We only have oxygen here. Abi? So we have MnO4 minus plus 5E minus. And I told us that if you are balancing oxygen in acidic medium, one oxygen atom is balanced with one water molecule. What's the formula for water? H2O, right? Now, how many water are you going to add like that? That will be what? 4H2O. Very good of you. So here you have Mn2 plus plus 4H2O. You have then balanced the oxygen. But in trying to balance oxygen atom, you have also included hydrogen. And I said, when you are balancing hydrogen, what do you use? You add proton, which is what? H plus, hydrogen ion. How many hydrogen do we have here? This is 4 and 2. That means you have H2 in 4 places. That's how many? That's 8. So I'm going to add it here to the other side. That's plus 8H plus. Do you understand? You have done everything needed for you to do here like that. So also the next thing to do is to cancel out some what? Sometimes we call it spectral species, right? Call it things that are common here. What you have included in trying to balance the equation, you're going to cancel them out. Now, what do we include? We were the one that included electron. We also included hydrogen and what? And water. But now, this is a very simple redox reaction for you. Well, there's some redox reaction whereby the two sides, which is oxidation and reduction, they will have oxygen. But here, we only have oxygen in one side. So we are just going to balance what? Cancel out the electron. But before you can cancel them out, you have to make them equal. And how can you make them equal? This is now pure mathematics, very simple one. You have 1 electron here, you have 5 here. How can you make them equal? Very simple. It's by multiplying this one by what? By 5, and multiplying this one by 1. So through that, you have made these two equations equal. This one. Now, if you multiply this all through by 5, what are we going to have? We have 5 Fe 2 plus to give 5 Fe 3 plus plus 5 electron. Then multiply this one through by 1. You're still going to have the same thing, right? You're still going to have MnO4 minus to give, plus 5E minus plus 8H plus to give Mn2 plus plus 4H2O. Now, before you can cancel out, we are going to add the two half cells together. That's the next thing. Add the two half cells together. That means we are going to add the reactant plus reactant, product plus product. Now, what do we have here at the solution site? We have 5 Fe 2 plus then MnO4 minus plus 5E minus plus 8H plus. Then to give, what do we have here? We have 5 Fe3 plus 5E minus. That's all for that one. Plus what? Plus Mn2 plus 4H2O. Now, once you have added them together, then you now write, we now cancel out the spectator species. That means what we included in balancing of the equation. Then what do we have to be equal there? So we have electron here and electron here. Electron will cancel electron. So what else do we have that is there? No, we have hydrogen here. We don't have hydrogen here. We have water here. We don't have water here. So nothing again to cancel out. Then we now add the two half cell equation together. So then add them together. Then add them together. So what else do we have now? We have a 5 Fe2 plus MnO4 minus plus 8H plus to give us, what else do we have here? 5 Fe3 plus Mn2 plus 4H2O. Now to confirm whether you are correct or not, so you can look at it very well. You have 5 ion, that's one manganese, 4 oxygen, 4 oxygen here, 8 hydrogen, 8 hydrogen. Then you have balanced this redox reaction. So this will be the end of the end of the class. Please, if you don't get anything there, you can backward as long as you have your phone in your hand. So you can just rewatch. So this is balancing in acidic medium. So we are going to be having another video to balance in basic medium. Please don't forget where we started. Our door is LIONEL. Please rewatch. Please do like, subscribe, and share to this platform. Share to your friends, share to your groups, share to your friends, your classmates, those any JAMB platform that you find yourself to be. So stay tuned to Chemistry Simplified, and you can also message this number to get added to our WhatsApp channel and also Telegram channel. Thank you very much. Stay tuned. God bless you.